gonna solve the problem which is based on exact differential equation. So guys, for that we have one differential equation and one condition is given, that is y of 0 is equal to 4. Now the question is how to solve this equation. So there are many methods to solve the differential equation. So one of the method is variable separation method, we have linear differential equation method, then we have the equation reducible to exact method, and we have exact differential equation method. Now the question is which method we must apply. So guys, for that we have to check one method. For example, let's say if I want to apply the variable separation method, then I should check whether I can separate x and y on both sides or not. So here it is not possible to separate x and y on both sides. So what is the other method? So let's say the second method is exact differential equation. Now to solve by exact differential equation, we must check the condition of exact differential equation. So the condition is like this: any equation in the form m dx plus n dy equal to 0 is said to be exact if dou m upon dou y is equal to dou n upon dou x. So guys, it means I have to check that it is satisfying the condition of dou m upon dou y equal to dou n upon dou x or not. If it is satisfying, I'll say it is exact. If it is not, then I have to check by some other method. So guys, let's start. So here, if you'll see the equation, so I can compare this equation with the form m dx plus n dy equal to 0. So I'll start my solution by that. So here I'll say comparing with m dx plus n dy equal to 0. So here, by comparing with this form, we can say that the value of m is this bracket. So here I'll say therefore m equal to 1 plus e raised to x upon y, and the value of n is this, that is e raised to x by y into 1 minus x upon y. Now guys, to prove that it is exact, we have to find the value of dou m by dou y and dou n by dou x. So let's find it out. So here I'll say therefore dou m upon dou y equal to, so for that I have to differentiate m with respect to y partially. So the derivative of 1 is 0 with respect to y, and the derivative of this is e raised to x upon y, and again the derivative of x by y. So in that x is constant, so x is as it is, and the derivative of 1 upon y is minus 1 upon y square. So guys, this is the value of dou m by dou y. Now let's find out the value of dou n by dou x. So let's differentiate this n with respect to x partially. So here now we have two terms and both terms has x. So guys, here I will use the product rule of derivative. So by that rule we'll get now the derivative of e raised to x by y is e raised to x upon y into 1 by y, because I am differentiating with respect to x partially. So I have differentiated u term, now v term as it is, that is 1 minus x by y, plus now v term, that is 1 minus x upon y. It means in the second term we have to find out the derivative of 1 minus x upon y. So guys, the derivative of 1 is 0, I can say it here 0, and the derivative of this minus x upon y with respect to x is just minus 1 upon y. So here I'll say it is 1, so it is 1 upon y. Now the e raised to x upon y term as it is, because here we are applying the product rule. So if we'll simplify this term, then here we will get e raised to x upon y into 1 upon y. So dou n upon dou x is equal to e raised to x upon y, and if I multiply this term to the bracket, then 1 into that term will be same, then minus x upon y into this term will be minus x e raised to x by y upon y square. Next, here as we got minus 1 by y into this term will be minus e raised to x upon y. So now here this plus and negative term will be cancelled, they are same, and we will get minus x e raised to x upon y square. Now guys, the value of dou n by dou x and here the value of dou n by dou y is same. So here I'll say therefore dou m upon dou y is equal to dou n upon dou x, and therefore the given differential equation is exact. Now since the given differential equation is exact, we can get the solution of this differential equation by the method of exact differential equation. So this is the formula to get the solution of exact differential equation. So it says we have to integrate m with respect to x by treating y terms constant, and then we have to integrate n with respect to y by just considering the terms which are free from x. So let's apply this. So first I'll integrate m with respect to x. So here I'll say therefore its solution is given by integration m dx. So the value of m is this. So I'll say it is 1 plus e raised to x upon y into dx plus integration of n dy. Now in the n we just have to consider the terms which are free from x. So guys, let's come here. So if you'll check n, then here we don't have a single term which is free from x. Now you must be thinking, sir, 1 is free from x. But don't make mistake guys, because if I multiply this bracket with e raised to x upon y, then this first term will become e raised to x upon y, and then it will have x term. So it means I don't have any term which is free from x. So what I'll do is I'll put 0 over there because I don't have any term. Dy equals to c. So it means I just have to integrate the first integration. So what is integration of 1 with respect to x? So it is simple, it is x plus integration of e raised to x upon y is e raised to x by y upon the derivative of this x upon y. Now I'll differentiate with respect to x by treating y constant because it is set. So that will be 1 upon y equals to c. So if we simplify this, then we will get therefore x plus y e raised to x upon y equals to c. So guys, here we got the solution of given differential equation by the method of exact differential equation. Thank you.